Hello everyone, this is Team 9. In the previous video, we learned about the pilloty structure of Hanyang Sujain River Pine. We also discussed the translayers. In this final video, we will take a closer look at the overall structure and totally focus on the improvements of the transfer layers. As mentioned earlier, Hanyang Sunjain River Pine apartment consists of a combination of a rigid frame structure in the basement and a wall-type structure in the above-ground levels. These two structures have contrasting characteristics. Therefore, the role of the transfer layers can be considered extremely crucial for structural stability. The transfer layers, as the name suggests, play a role in safely transmitting the load from the upper structure to the lower structure, which has a different environment. Then, what type of the structure is used for the transfer layers in Hanyang Sujain River Pine apartments? It is the transfer beam. The transfer beam receives the load from the wall-type structure of the residential units and safely transfers it to the rigid frame structure, which includes the first floor and the basement parking structure. This transfer beam has one significant characteristic. The depth of the transfer beam is generally designed to be 2.5 to 3 meters or more, with an approximate calculation of 10 cm per floor. In Hanyang Sujain apartments, the transfer beams are designed to be approximately 1.4 to 2.2 meters in depth. This depth is considerably deeper than the depth of beams typically used in buildings. So it needs to be planned to occupy the height of one floor or being thicker than the slabs or ordinary building structures. We have a question regarding to the Hanyang Sujain River Pine apartments, which are subject to height restrictions due to cultural heritage laws and the terrain level differences. The use of thick transfer beams in the design does not allow the utilization of the corresponding height for residential purposes. This, in turn, affects the profitability during the sale of units and is considered inefficient. So, are there other potential improvements in the design? Based on this consideration, we have researched on the improvement plans. Firstly, what if we don't use transfer beams at all? When using transfer layers, the load from the upper structure is transferred to the pilloty columns through the transfer beam or transfer slab. One advantage of this approach is that the positions of the pilloty columns can be determined independently of the locations of the upper structure walls. However, for the accommodation of formatting the rigid frame structure, due to the installation of transfer beams, may require larger cross-sectional areas for the pilloty columns or additional pilloty columns. As a result, this leads to lower space utilization, increasing of construction costs, and longer construction periods as disadvantages. We have investigated an approach to improve the structure design, which involves placing the pilloty column aligned with the upper structure walls. In this method, the load from the apartment structure is simultaneously transmitted to both the pilloty columns and the structure walls, eliminating the need for a transfer layer. By eliminating the transfer layer, there is no waste of height equivalent to one floor. This approach has three main characteristics. First, to prevent additional stress due to eccentricity, or excessive bearing stress between the structure walls and columns, the size of the pilotic columns are assumed within the range of 40 to 60% of the length of the upper structure walls. Second, the pilotic columns are positioned at the center of the length direction of the structure walls to suppress eccentric load. Third, to ensure that one face of the pilotic columns aligns with the outer face of the structure walls, the pilotic columns are eccentrically positioned with the center of the structure walls. By adopting this approach, the need for transfer beams or transfer slabs, which forms the transfer layer, is eliminated, resulting in increased space utilization. Additionally, it reduced the number and cross-sectional area of the pilotic columns, minimizes construction costs, and shortens the construction period, thereby enhances cost effectiveness. We have proposed this structural approach to the site, highlighting its advantage. However, despite of the advantage it has, it was determined that this approach is not feasible on the site due to the drawback of reduced efficiency in the underground parking lot, as the pilotic columns and columns of the rigid frame structure are constrained by the structure walls. Therefore, the use of a transfer layer was deemed essential at our site to maximize the efficiency of the underground parking lot.
However, the transfer beam in the architectural plan blocks the entire area except for the core, making it unusable in architectural space. As mentioned before, the transfer floor supports the upper structure and transfers its load to the lower structure. Therefore, we have explored alternative transfer structures that can replace the transfer beam and allow the architectural space to be utilized. One such option is a truss system. By incorporating trusses into the transfer layer, it allows for utilizing a greater height range of 3 to 4 meters compared to transfer beams. The advantage of this approach is that the height can be used as a single architectural space. A transfer truss is a common truss system that spans between reinforced concrete walls or columns, and it receives forces from disconnected columns located at the nodes. The characteristics of a transfer truss includes its lighter weight compared to a transfer beam. Additionally, the shape of the truss resembles a spider web, known as an open web structure. This structural form facilitates are easier to integrate with the building's architectural system compared to a straight transfer beam. In fact, by increasing the depth of the truss to a certain number of floors, each component becomes thinner, allowing it to seemingly integrate into typical residential units. Examples of buildings that have utilized transfer truss include the Standard Hotel in New York and the Arts Business Hotel in Lisbon. However, when using trusses as architectural space, there are limitations in terms of obstructing views and constraints on horizontal and vertical lines, making it difficult to utilize them for residential purposes. Apartments thrive on having a significant amount of residential space as it directly impacts profitability. However, utilizing 3 to 4 meters of space that cannot be used for residential purposes is not suitable for the structural approach of the apartment. This limitation hinders the potential for maximizing the revenue-generating residential areas. Consequently, the current structural approach with transfer truss is not considered optimal for Hanyang Sujain apartment due to the inefficiency in utilizing the available space. Despite the existence of alternative methods for the transfer layers, each method has its own distinct advantages. However, Considering the most crucial economic aspects and their depth in apartment construction, using transfer beams in a transfer layer was concluded to be the most suitable. So, in the most efficient scenario, using transfer beams, what aspects need to be improved to advance the current construction?
We have explored construction methods in order to construct transfer beam more effective in the site. In the construction of transfer beam, the construction method of RC, PC, and half PC varies depending on whether concrete is placed on site or not. In addition, there are two separate construction methods, the bottom-up sequential construction method and the fast-up method. Let's now explore possible improvement measures based on whether concrete is placed on site or not. The method of directly placing reinforced bars and installing formwork on site to cast the components is referred to as the RC method. On the other hand, the PC method involves using precast components manufactured in external factories instead of casting concrete on site. The construction process of the PC method is similar to RC method, with the difference being the use of PC concrete produced in factories. The advantages of PC method include enhanced quality due to mechanization and automation in factory production, as well as consistent quality. Additionally, since there is no need for on-site placing, construction time is reduced and site work is simplified.
However, there are some disadvantages to consider. The PC method involves heavy lifting operations, relies mostly on visual inspections for quality control, and raises concerns about transportation costs and potential component damage. It also requires specialized equipment for installation. Furthermore, since the columns and slabs are not cast as a single unit, there is a risk of leaks at the joints where the columns and slabs are connected. Fixing these joints can be challenging, and the lack of continuous support makes the structure vulnerable to deflection. If cracks occur at the joint, they can have a detrimental impact on the entire structure, necessitating additional reinforcement, regular maintenance, and inspections.
To address the drawbacks of the PC method, the half PC slab method can be used. The half PC slab method is characterized by the use of half PC slabs, which are different from the full PC slabs used in the original PC construction. In this method, PC columns and PC girders are installed and half PC slabs are placed on top. The upper portion is completely by casting concrete on site to form the floor slab. This construction method combines the advantages of the PC method and on-site casting method.
One characteristic of the half slab method is that precast elements are manufactured in a factory and then placed on vertical members such as walls or columns, followed by on-site concrete casting on top of them. The precast slab acts as a formwork, eliminating the need for formwork construction and removal. It also provides a secure working space, enhancing work efficiency. Half-pitch slab, which can complement the vulnerability of joint, which was the biggest drawback of the PC method, use G-bar, spiral, and truss reinforcements to ensure joint unity with cutter and rough surface finish.
When using this half PC slab method, you should consider the applicability to the method, production, process plan, equipment plan, concrete curing period, and consider the connection with the site. It should also be balanced to prevent cracks or damage during transportation and loading. The following table compares the characteristics of the concrete site installation method, the full PC method, and the half PC method. In terms of price, the concrete site installation method is the most advantageous, but the concrete site installation method is the most disadvantageous at the time of construction. The half PC method is a proper complement to this, which is cheaper than the full PC method, and the construction period is shorter than the concrete site installation method. The half PC method, which can compensate for the disadvantages of the concrete site installation method and the full PC method, was found to be the best way, and we proposed this to the site.
The half-PC method has been identified as the optimal solution for addressing the shortages of both on-site concrete casting methods and full PC methods.
Now let's look into improvement measures that can be applied based on construction method which are used in Hanyang's construction. The commonly known method, the bottom-up sequential construction method, and the PESTON method. The current construction method used in Sujain involves the sequential construction of the framework, starting from the basement rigid frame structure and progressing upward to the upper level wall structure, followed by concrete casting.
The PESTON method is a combination of the word fast, which means skipping the middle floor and carry out the construction of the high-rise, and the word up, which means to carry out the construction in the upper direction. In other words, it is a method of constructing high-rise buildings divided into low and high-rise buildings based on the transfer layer where the plane state is changed, and it was developed to improve the problems of construction period due to the sequential construction of high-rise buildings with transfer layer. Currently, the method used in Hanyang Sujain requires an average of 1 month of construction period per floor because the underground or lower floor below the transfer layer has a larger area and lower work efficiency than the high-rise reference floor. However, the fast-up method has the advantage of reducing construction period for more than 2 months based on 4 basement floors because the fast-up method is supported by the core and the column, constructs the transfer layer before the lower layer, and then carries out the construction of the high-rise immediately while using the transfer layer as a load support. Then, let's take a look at the detailed construction process of the fast-up method. The first step is to construct a core and a column to support the transfer layer. In order to start the high-rise above the transfer layer early, the transfer layer must be able to stably support the construction load of the high-rise. Construction of cores and columns is carried out in a proper manner according to the design plan of the building to be constructed. The second step is the construction of the transfer layer to support the high-rise above the transfer layer. At this time, since the columns constructed in the first step are not connected to each other and are constructed independently, there is a concern that if the construction load of the transfer layer is applied to the column during the second step, the construction load of the transfer layer may not be effectively distributed and supported. Therefore, to prevent this, a temporary support frame is installed that connects the columns to each other. The temporary support frame connects the columns in the form of horizontal or brace, but since it is a temporary material, it is installed in a form that is easy to install and dismantle. The transfer layer proceeds by constructing the transfer beam and transfer slab as shown in the following figure. It is the order of constructing the transfer beam connecting the columns and the transfer slab connecting the transfer beams. At this time, the transfer slab can be constructed by connecting the transfer beam and the transfer beam with the floor plate, installing a side mold on the outside, arranging reinforced bars over the floor plate, and placing concrete. The last step is to complete the transfer layer and carry out the construction of the lower and higher floors at the same time. At this time, since the low-rise part is already constructed with a core and a column, only an interlayer framework is carried out in the upper direction, while the high-rise part must carry out the entire framework in the upper direction. In this way, if the construction of the transfer layer is carried out using the fast-up method, it has an advantage of shortening the construction period.
When we reviewed the above method, we thought that the best way is to combine the half-PC method and the fast-up method. The reasons are as follows. When we used the fast-up method, we found that the construction period of the two basement floors would be shortened by about 1 month. This is about 4% of the total construction period of 32 months, and when we use a half-PC method, we found that the construction period is reduced by about 10%. In addition, when using the half-PC method, the labor needed for the construction process has been reduced by about 50%. However, the price of materials for PC has increased by 25% compared to the RC method. Overall, the economic benefits were not big and rather damaging, but when fast-up method and half-PC method were combined, improved stability, high-quality construction, and elimination of labor were expected. Therefore, based on the expected effect above, we propose the method that combines the fast-up method and the half-PC method on the site.
However, the response from the field was not that good. While the half-PC method presented a good solution by addressing the drawbacks, it was not significantly more cost-effective compared to the existing methods when considering the equipment, expertise, and technical implementation. Therefore, at Hanyang Sujain construction site, they decided to stick with the conventional method we have been using.
During this project, we studied other methods besides the method used in field, made suggestions to the site, and developed and presented the disadvantage of the method used in field. A new version of the construction method was created by applying the latest technology, and there were many better construction methods than existing construction method. But it was difficult to actually apply them to the site. Therefore, we realized that interest and study in various high-tech technologies are needed for more efficient and safe construction as the latest technologies are actively introduced to this site in the future. Thank you for listening.